Modern-day helicopters and drones have difficulty landing and taking off of uneven terrain. On a large scale, helicopters can tip when landing on unlevel ground or have their propellers collide with the ground. On a smaller scale, drones can also tip, but more frequently won't even be able to take off due to system safeties. Companies such as DARPA have invested a lot of money in finding the solution to these problems and have created a helicopter that adjusts its legs based on sensor input about the terrain beneath before the landing. Our design features retractable legs that level after landing. These legs retract for flight and for the landing to prevent them having to bear any of the impact.
Originally, we looked into the option of purchasing a drone and adapting leveling gear to fit that, but given the high cost and the complexity of rewiring the circuitry, we decided instead to make our own. We thought that would be more fun. From there, we outlined our most important design metrics, the first being that it have a flight time of at least 5 minutes, the second that it could level itself from a maximum of 20 degrees, and the third that this be done by a user via the transmitter. From there, we worked to optimize the leveling gear, exploring different options for number of legs, the number of joints, the angle at which that they would deploy, etc. We landed on a 4-legged, double-jointed system that would align to the axes of the accelerometer that we would use to level the drone.
Given our design metrics, our major goals were having a leveling system capable of lifting the weight of the drone and enough thrust to accelerate the drone off the ground. As both goals are directly related to the drone weight, we began by selecting lightweight structural materials in order to maintain the weight of the drone under 4 pounds. Given our initial weight estimate, we calculated necessary thrust of 9 pounds, as well as a necessary torque for the servos of 60 ounce-inches. Next, we will demonstrate our leveling system. Unfortunately, because of a malfunction of the receiver, we are not capable of demonstrating flight.
So we have a number of planned design modifications. They're broken down into 2 big categories. Prototype modifications, which would allow our prototype to run more smoothly. For obvious reasons, we would clean up the circuit. As it stands, it poses a potential safety hazard. We would also change a number of the materials to make it lighter. We would change the servos to make them higher quality, higher accuracy, and less prone to twitching. A number of the design modifications we have planned, primarily removing the servos from their joints, from the joints of the landing gear, to take the load of the legs off of the servo joints, as well as incorporating a gyroscope and into the accelerometer system to improve the accuracy of the leveling system at low angles.